3.11 asks us to analyze the function x to the fifth over 5 plus x to the fourth minus 4x cubed. And the first thing we're going to do is analyze the first derivative method. So first thing we're going to do is we're going to analyze increasing and decreasing. And so to do that, we're going to take the derivative. And the derivative of this is not too bad. It's 5x to the fifth over 5. So that is simply x to the fourth. Notice your 5 and your 5 cancel. And then we've got 4x cubed minus 12x squared. So here's our function, x to the fourth plus 4x cubed minus 12x squared. And now we just have to figure out, where does this thing equal 0? Notice it always exists. So we just have to solve x to the fourth plus 4x cubed minus 12x squared equals 0. I would factor out an x squared and then get x squared plus 4x minus 12 equals 0. And then I would try to factor what's left. And it looks like we can factor this into x plus 6 and x minus 2. So I think those are our two results. Notice 6 times negative 2 is negative 12, and then 6x minus 2x gives us that 4x. Okay, so there's our solution. So now I just take that and look really closely at it, and notice I get three answers. One answer is x equals 0. The next answer is negative 6, and the last answer is 2. I just took each factor and set it equal to 0, and that gave us my 3 points. So now I'm ready to draw my number line. And so my number line has 0 on it, I have 2 on it, and I have negative 6 on it. And I have to check all 4 spots. So let's go do each spot one at a time. So let's just pick something smaller than negative 6. And we'll go negative 7 perhaps. How about maybe negative 10 would be good. That sounds easier to put in my equation. And I'm just going to make all this scratch paper. And we're going to put this in, actually negative 7 is just fine. Okay, so our equation is x squared, x plus 6, and x minus 2. So I get negative 7 squared, negative 7 plus 6, negative 7 plus 2, minus 2. And that looks like I get 49 times negative 1 times negative 9. It's 49 times positive 9. You know, why even figure it out? I know that it's a positive number. So I know that this here must be positive, and so I know my function must be increasing on that section. All right, let's try my next one. Pick a number between 0 and 6. How about negative 5? That seems like a good option. And so we'll do negative 5 squared times negative 5 plus 6. Negative 5 minus 2. That gives me 25, positive 1, and negative 7. And again, I could figure this out in detail. I think it's negative 175. But it doesn't matter. But I know it's positive times negative. So I know it must be a negative number. So that part must be negative. So I must be decreasing right here. Okay. Let's try a number in this section. So I had negative 7 over here, negative 5 over here. Oh, I should have done negative 1. Well, who cares? Okay. Now let's do 1 here. And then we get 1 squared times 1 plus 6 times 1 minus 2. And that gives me 1 times 7 times negative 1, which is negative 7. And so this is clearly a negative number. So I'm clearly decreasing on that part. And now finally, I need something on this side. 3 looks like a good number. So let's pick 3. If you're picking different numbers than me, no big deal, as long as it's a number bigger than 2. So you could pick 3, 4. You could put pi in there if you're a glutton for punishment. You could put 10 million in there. You can kind of pick whatever number you want in that region. I think 3 is a nice, reasonable number to put in. 3 plus 6, 3 minus 2. It looks like I get 9 times 9 times 1. So 81 is a positive number. So I get positive, and I get that it's increasing. So I can see already from my picture, I can already kind of get some sort of rough picture of what my graph is going to look like. So I know my graph is going to increase. Then I know it's going to decrease. It's going to decrease some more. and it's going to increase. So I'm going to go up, and then I'm going to go way down, and then I'm going to come up again. So I can already kind of see what my graph is. Now what I'm not sure is how it curves along the way, right? So I'm not sure about the curviness that happens as I go through this graph. So we'll work on that in the next section. But one thing I didn't mention earlier was, how do we write our answer to this problem? Well, the way I write my answer, there are a few ways. Option number one is to use what we call interval notation, which I like. In interval notation, I would pick this interval, which is negative infinity to negative 7. So I'm going to write increasing, and I could put negative infinity to negative 7. And then a little union. In interval notation, union means also or as well. The section from 2 to infinity, so 2 to infinity. And then my decreasing section, I could have done negative 6, and it's decreasing all the way from negative 6 all the way to positive 2. So this would have been a pretty reasonable way to write my answer down using interval notation. What's another way that I could have written it down? Another way I could have written it down was I could have said, well, increasing, it increases when x is less than negative 7, or when x is bigger than 2. So I could have just used words here. And then for decreasing, I could have said, well, x must be bigger than negative 6 and less than 2. So I could have used kind of inequalities to describe it. You could also kind of describe it with words or something else. Either any of these are fine. I don't remember exactly what the book does. It may do interval notation, or I can't remember exactly. Okay, but those are how we write down the solutions for A. And furthermore, we saw when we looked at it earlier, we kind of come up here, way down here, we can already see where maximums and minimums must be. So we see that we must have a maximum right here because we switch from increasing to decreasing, and we must have a minimum right there. So I can see right now that we have a local max at x equals negative 6, and a local min at x equals 2. So I've already figured out where that local min and that local max are. All right, so let's hang on to that, and then let's come back, and now let's look at concave up and concave down. So in order to do concave up and concave down, so that was part A and part B. So now for part C and part D, I'm going to have to look for concave up, concave down, and that means I'm going to have to do the exact same thing, make the same number line, do all the same analysis, except this time I'm going to be using the second derivative. So all I do is take the derivative of that answer, and that gives me 4x cubed plus 12x squared minus 24x. Let's simplify that just a little bit. Oh, okay, and then notice I want to figure out where that's equal to 0. So we'll have 4x cubed plus 12x squared minus 24x equals 0. Again, there's no chance that this doesn't exist because this is a nice friendly equation. I'm going to factor it and just see if that helps. So I'm going to factor out a 4x, and then what I'm left with is x squared plus 3x minus 6 equals 0. Well, one solution is that x equals 0, but this solution I have to try to factor, and do you want to know the bad news? It doesn't factor. So since it doesn't factor, we have to figure out how to solve this equal to 0. So to solve this equal to 0, I'm going to use the quadratic equation. All right, and you all remember the quadratic equation? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go. So there's your quadratic equation. And so I'm just going to stick my a, b, and c in here. And so my quadratic equation gives me negative 3 plus or minus the square root of 9 minus, here let's go ahead and write 3 squared minus 4 times 1 times negative 6 all over 2 times 1. And so as I simplify my quadratic equation, it gives me negative 3 plus or minus the square root 9 plus 6 times 4 is 24, 9, so it looks like 33 all over 2. So by the way, that's a pretty reasonable answer if I wanted. So it looks like my 3 points are 0, 3 plus square root of 33 over 2, and 3 minus square root of 33 over 2. What if I go ahead and put those in my calculator so that I have decimals to look at those two? So negative 3 plus the square root of 33 all divided by 2. So when I use the plus sign, I get 1.37. And when I use the minus sign, I get negative 4.37. So those were my two answers that I got. What if I use those instead? That might be a little bit easier to work with than the other ones. Okay, so I'm ready now to take those three answers, put them on my number line, and start tackling where is this function concave up and concave down. So I've got my number line right here. I have 0 here. I have 1.37 and negative 4.37. And those are the three that I need to put into my equation. What equation am I using? I'm using the second derivative equation, which is 4x times x squared plus 3x minus 6. And so that's what I'm putting those into. I'm putting them into the second derivative. And so I'm trying to analyze where that thing works. All right. Okay, so let's work with that and see how they go. Let's pick all of my points. Something less than here, negative 5 sure seems like a inviting choice, doesn't it? So that gives me 4 times a negative 5 times negative 5 squared, which is a positive 25, minus 15 minus 6. And so this looks like negative 20 times, let's look at this. So this is positive 10 minus 6, so times 4. So it's a negative 80. But what's important is that it's negative over here. So we're concave down on this region. So between negative 5, or when we're less than negative 4.03, we're concave down. So now I need to pick something in this region. I'm going to pick negative 1, because that seems like a nice friendly number to work with. So I'm going to do 4 times negative 1 times 1 minus 3 minus 6. And it looks like I've got negative 4 times negative 8, which is a positive 32. But again, the important part is that it's positive. What the exact number is not near as important as just whether it's positive or not. So now I'll pick 1 right here. That seems like the right answer between 0 and 1.37, doesn't it? 1 is a nice, easy number to work with. 4 times 1 times 1 plus 3 minus 6. So that gives me 4 times negative 2, which is negative 8. And importantly, that's negative. And so that's concave down. So now I need something bigger than that. And I'm going to pick 2. So that gives me 4 times 2 times 4 plus 6 minus 6, which is 8 times 4. So I get 32. And so that's positive right here. And so what you see is that our graph, this very nicely just switched and just went concave down, concave up, concave down, concave up. So it just switched. And now we can kind of see what our graph's going to look like. It's going to have that shape, that shape, that shape, that shape, that shape as we go along. By the way, if we wanted to include an answer for part C, you might use one of the two notations that we did earlier. So what if I use my interval notation, and I'll say it's concave up from negative 4.37 to 0 and from 1.37 to infinity. And then I'll say it's concave down from negative infinity to negative 4.37 and 0 to 1.37. So this is a pretty reasonable way to write your answer. If you want to write it with less thans or some other method, I don't really care too much. Now, do we have any inflection points? The answer is yes. We can already see that we have inflection points because right here it switches, here it switches, and here it switches. So all three of these points were inflection points. So we have inflection points at x equals negative 4.37, x equals 0, and x equals 1.37. So we have 3 inflection points. So we can kind of get all this information. Okay, so now what we're ready for is we're ready to put these two together. So we're ready to put this picture with our increasing and decreasing together with this picture with our concave up and concave downs to try to get ourselves a graph of our equation. Okay, lots going on here, but I am confident that we can do it. So let's draw this. Let's put 0 on here. Let's put -6 on here. Let's put 2 on here. 1.37 and -4.37. So here's all of our points. Just like last time, I'm going to kind of try to use some labeling to label things. So I know that in this section, it was increasing. So if I go back to my results, it was increasing on this side. And then it decreased over this entire section. And then we increased again. Oh, wait. Sorry, it decreased. It kept decreasing the whole way. And then it increased again here over at -2. Okay, now let's come to the other two. And here I'll write it in red. So in this section, we know that it's concave down. In this section right here, we knew that it was concave up. And then in this section here, it was concave down. And in this section here, it was concave up. So we can kind of start to see our picture. And we see that it's increasing. We see that we have a maximum right here at 6. So what if I put my maximum on here? By the way, this maximum is actually like 600 or something. So if you were to go try to graph this, you would have to have a really scaled out graph in order to see this. But okay, so our maximum is right here, and we're concave down. So we're increasing on this side of the maximum and decreasing on this side of the maximum. What happens right here? What happens right here is an inflection point. So instead of curving this direction, we now start to curve the other direction. And we start to curve the other direction right through here. And we keep curving here until we reach this point. And then when we hit this point, the curviness changes. And we start curving this way. So now we're curved down. And then we hit this point, our curviness changes again until we hit our minimum. And then we come back up. So you can kind of see it now just by looking at our derivatives. We can start to get a picture of how our graph is shaped. So concave down, concave up, concave down, concave up. Increase, decrease all the way, and increase. But notice, just looking at the increasing and decreasing didn't really tell us what was happening here. It didn't tell us about the curviness that's happening here at this point. Importantly, it didn't tell us right here that we have kind of this flattening out shape in these inflection points at these different spots. All right, so that's how we tackle 3.11. Again, I know there are lots going on these problems, but I believe in you, and I believe you're going to be able to make it through. All right, so good luck. Keep working on these. Go to 3.9, so go back 2 pages in your notes, 3.9 on page 67, and try it, and I'll see you there.